Hi guys, we're going to go through our bonding Regents Prep. I know it is your absolute favorite topic. It is mine too, but we're just going to kill it on the Regents this year. So let's go ahead and start. 1. Which statement describes the substance that results when electrons are transferred from metal to nonmetal? I'm going to focus here on transferred metal to nonmetal. I know if that happens, then it must be ionic. So contains ionic. I don't like covalent, so right here, and then I'm focusing on my melting point. Well, if I'm ionic, I'm going to actually have really high melting point because ionic things are very often solids. So that means I'm not going to melt very easy. So transferred is what leads me to the ionic part. And the fact that they're solids leads me to the melting point. So 2, based on the bond type, which compound has the highest melting point? We just said that ionic things had really high melting points. So let's see who's ionic. I gotta have a metal and a non-metal. So let's see, 2 non-metals, lots of non-metals. Ooh, Ca, that's a metal. With Cl, non-metal. Boom, choice 2. 3, the unusually high boiling point of water is due to the presence of, anytime you see this phrase, unusually high boiling point of water, you can always guarantee that that comes because of its hydrogen bonds. Remember, hydrogen bonds are when H is with N, O, or F. Those are really strong. Really strong forces, so that gives it the high boiling point of water. 4, what is the correct Lewis electron dot structure for the compound magnesium fluoride? So let's see, magnesium is a metal, fluorine is a non-metal, so this is ionic. So I want an ionic drawing, so actually I'm going to get rid of 4, I'm going to get rid of 1, because when they show the dots in between, that's really like a line, and this would be like a line, and so those would be covalent. So I want to think, okay, so it's either 2 or 3, so it's either with 2 F's or it's with 1. So let's see, magnesium, let's crisscross and check this out. Mg is plus 2 if I look at my reference table. F minus 1. So if you crisscross, you get MgF2. So I like 2 F's there, so I like choice 3. Make sure you always crisscross if you figure out it's ionic. Okay, number 5. Which elements combine by forming an ionic bond? All right, we're really focusing on the ionic for now. I need a metal and a non-metal. So sodium's a metal, potassium's a metal, so that's out. That's 2 metals. Carbon and oxygen, nope, that's out. Those are 2 non-metals. So non-metals, I have 2 metals. Sodium and oxygen, I have a metal and a non-metal. I really like that. So I think I'm going with 3. Carbon and sulfur, yeah, they're both non-metals. So that's right, that's out. So choice 3. 6, what type of molecule is CF4? So this is, CF4 is 2 nonmetals, so it is covalent. So I think covalent can be either polar or non-polar. So if they ask about the molecule, they want to know about its shape. So I'm thinking is it symmetrical or asymmetrical. So if I'm, let's see, I end in a 4. So if I end in a 4, I'm going to be symmetrical. So let's see, symmetrical, asymmetrical, asymmetrical. Get rid of those. And then am I polar or non-polar? Well, if I'm symmetrical, I'm non-polar. So remember, you can always look at the ending. If it ends in an even, it's going to be symmetrical. If it ends in an odd, it's going to be asymmetrical. That's if they say what type of molecule is it as far as polar or non-polar. They say what kind of bonds. We're going to look at electronegativities. 7. Given the formula, what is the total number of shared electrons in a molecule? Well, shared is when I have lines. So let me see how many lines I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 lines. But remember that a line is really equal to 2 dots. So I really have 2 times 11. So I have 22. First one. And this agrees. Number 8, given the balanced equation I plus I gives you I2, which statement describes the process represented by the equation? So I see that I have two things coming together to make one. So here I'm forming a bond. So I like a bond is formed. I do not like a bond is broken. So I'm formed, so what happens to my energy? When I form a bond, they're really happy. So that means that they kind of breathe that sigh of relief. So I like choice 3 because energy is released. 9. Which electron bond structure represents a nonpolar molecule? So again, they're talking about a molecule being polar and nonpolar. So I'm going to look at its shape. And so I'm going to see if it's symmetrical or asymmetrical. If I look, this looks pretty symmetrical. I've got 4 H's around one C that kind of cancel each other out. Boom, choice 2. 10. When metals combine with nonmetals, metallic atoms tend to. So let's focus on what metals do. Well, if I look at my periodic table, here's an example of some metals. They all have positive oxidation numbers. Get a little closer. Yep, positive oxidation numbers. So that means that they're going to make positive ions. So I like those two. I don't like negative ions. And then so I'm thinking, well, does that mean they lose or gain electrons? Well, electrons are negative. So if you become positive, you actually lose your electrons. Boom, negative electrons. 11. A substance that has a melting point of 1074 K conducts electricity when dissolved in water, but does not conduct electricity in the solid. Ooh, that's important. Conducts in water, but not as a solid. So they want to know, well, what is this? Is it ionic, metallic, network, or molecular? Well, network and molecular, those both mean covalent, and covalent things never conduct, so those are gone. Metallic solids, well, those things would conduct always. So always conduct. So if I'm ionic, ooh, that's special. It's ionic. Ionic things, they kind of break into their ions. Example, NaCl. When it breaks up, I've got Na plus and Cl minus. So ionic solids, when I put them and make them aqueous, dissolved in water, they'll break apart and they'll conduct electricity. Okay, number 12. Which formula represents a molecular substance? I remember that molecular is the same thing as saying covalent. And covalent is going to be non-metals only. So non-metal only. So let's just figure out who's non-metals. Well, I have a metal there, so you're out. I have a metal there in Li, you're out. C and L, both non-metals. I like that. And if you notice, my answer choices are actually out of order. So it goes 1, 3, 2, 4. So just make sure that's your answer. 13. What is the total number of electrons shared between a double covalent bond between two atoms? So double covalent, so we're talking about 2 lines. So the total number of electrons, I have 2 times 2, so I'd have 4 electrons. 1 line equals 2 electrons. 14. A substance was found to be soft, non-conducting solid at room temperature. It is most likely. All right, it is soft and does not conduct electricity. So soft and does not conduct electricity. I want something that's covalent, for sure. So I don't see covalent right in there. Ooh, but I see molecular. Molecular and covalent mean the same thing. So boom. 15. Which factor distinguishes a metallic bond from an ionic bond or a covalent bond? So they want to know, like, what about metals is special? And metals is always very special that they have electrons that move. So choice 1 is super special, the mobility of electrons. Remember that we say that they have the sea of electrons? And that's just because they move. So 16, very important, by the way. Let me put a star by this. That's going to be on there. 16. Based on electronegativity values, which type of elements tend to have the greatest attraction for electrons in a bond? So based on electronegativity values, greatest attraction. Let's see. I can look this up. So if I go to my table S, I can actually look and see my electronegativity values, and they're asking me to compare metals, nonmetals, metalloids, and a noble gas. So if I look, let's do this. Here's some examples. Let's look at electronegativities. Well, hydrogen, that's a nonmetal, 2.2. Let's see. Neon, that's a noble gas. Well, nothing, so don't consider that. Let's see, I need a metal. Lithium, 1.0. Let's see. I need a metalloid. Let's go with GE 2.0. So out of all of those that I picked, hydrogen was actually my highest. And actually, if I look at my other models, carbon 2.6, nitrogen 3.0, fluorine 4.0. So it looks like my non-metals are going to have the greatest attraction. So if you're explaining that, just pick a couple of examples and write them down for me. All right, number 17. The degree of polarity of the chemical bond in a molecule of a compound can be predicted by determining the difference in. So if I want to know something is polarity, I want to know if it's polar or non-polar, well, I can look up the electronegativities of the bonded atoms. Remember that if I have electronegativity differences, let's see, 0 to 0.4, that's going to be our non-polar. 0.5 to 1.6, that's going to be our polar. And if I'm ionic, I'm going to be greater than or equal to 1.7. So electronegativity is always look up table S for questions if they can give you specifics. 18. What structural formula represents, let's see, a dipole? So dipole, I'm thinking dipole means something that, sorry, I'm right in your way, is polar. So if I'm thinking, well, what's polar? Well, let's think, I want something that would be asymmetrical. So, symmetrical. Choose one. Asymmetrical. 19. What type of bond is formed between two chlorine atoms in a chlorine molecule? So, chlorine molecule would be Cl2. So, that's two non-metals. So, I'm going to go with non-polar covalent. If you drew it out, you just have two Cls looking pretty balanced with each other. Pretty symmetrical. No electronegativity difference. 20. Which compound has the greatest degree of ionic character? So if I look, I want to decide, well, who is the most ionic, basically. So I want the greatest electronegativity difference. So I can figure that out if I go to my table S. And I want to look this stuff up. Let's see. So if I go to my table S, which is where you should be going, I'm going to see, so I'm not going to show you each one, but this is where I'm going. So, let's see. Si would be 1.9, Cl 3.2. So 3.2 minus 1.9. And G, if I look it up, that's going to be 1.3. So 3.2 minus 1.3. NaCl, Na is 0.9, so 3.2 minus 0.9. And AlCl3, Al is 1.6, so 3.2 minus 1.6. Well, the greatest difference, I can actually put those in, but it's going to be two numbers that are the furthest apart. So 20 is choice 3. 21. When a sodium atom reacts with chlorine to form a compound, the electron configuration of the ions forming the compound are the same as those in which noble gas? What are they talking about? So sodium goes with chlorine to form a compound. What could they possibly be talking about? Well, probably NaCl. And we know that NaCl comes from Na as a +1 ion and Cl is a -1. So actually now I'm going to go to my reference table, and what I'm going to look up is their electron configuration. So if I look, Na right here would be 281, but I said that it was +1, so instead of 281, I say +1 means I lose 1. Look at that. Na is 28, or Na +1 is 28, and then Cl minus, again, I'm going to look it up right here, 287. but that means I add 1, so it's really 288. So now I'm just going to look, well, who's 28 and 288? 28 is neon, 288 is argon. So neon and argon. Choice 2, NeAr. 22, which molecule of hydrogen bonding is the strongest? So hydrogen bonding, I remember it's H with N, O, or F. So Cl, Br, I, no, oop, HF. Boom, got my answer. Always remember that. H with N, O, or F. 23, which element consists of positive ion immersed in a sea of mobile electrons? Sea of electrons. That means the electrons move. So electrons move if I'm a metal. So let's find a metal. Sulfur, calcium. Oh, yep, found it. Calcium is a metal. 24, what kind of energy is stored within a chemical bond? So stored energy, well, stored, potential. Stored energy is potential energy. Remember, kinetics, the energy of motion. Activation energy starts a chemical reaction. And then free energy, well, we don't really talk about that in Regents, so you don't even need to know. 25, which kind of compound generally results when non-metals chemically combine with metals? So I have a non-metal with a metal. Well, metal plus non-metal is always ionic. Molecular means covalent, network means covalent. And it's 2 non-metals or more, 2 or more non-metals. And metallic, that's metals only. So ionic, metal, non-metal. 26, the degree of polarity in a bond is indicated by, so we're just talking about this polar and a bond. I'm going to look up the EMAG values. I'm going to look that up on table S. So the ionization energy difference, no. The shape of the molecule, no. That's not for a bond. If I'm talking about the molecule, yeah. The charge of the kernel, what the heck's a kernel? They're just talking about the nucleus. But, nope, it's not that. So 4, the electronegativity difference. Yep. It's that one. All right, 27. We're almost done with multiple choice. So close. STP, potassium is classified as, well, potassium, that's K. If I look at my reference table, K is way over on the left side out of that whole thing. So it is a metal. So, a metallic solid. 28. Which terms describe a substance that has a low melting point and poor electrical conductivity? We've seen a question just like this. Low melting point is always going to be something covalent. So I want something, oh, I like covalent, but I don't like metallic. I don't like ionic or metallic. I don't like ionic. Ooh, this word molecular. Molecular and covalent mean the same thing. So choice 4. 29. Which particles may be gained, lost, or shared by an atom when it forms a chemical bond? So gained, lost, or shared. Electrons. I'm losing them. I'm gaining them. I'm sharing them. 30. In a nonpolar covalent bond, electrons are, let's see, nonpolar covalent. So then a mobile sea of electrons? No, that's my metals. Are they transferred? Nope, they're not transferred. That's ionic. Are they shared equally or shared unequally? Well, let's think. Nonpolar. No poles. No difference. So they're going to be pretty equal. They're going to share equally. Choice 3. All right, short answer. We are getting there. Promise, almost done. So 31, explain in terms of electronegativity why the HF bond is expected to be more polar. So in terms of electronegativity, why it is more polar. Well, if I look up my electronegativity differences on table S, I would see that F is a 4.0 electronegativity and I is less than that. So HF is going to have a greater electronegativity difference. A greater electronegativity difference. By the way, that's always the answer to that problem. If you're more polar, then you have to have a greater electronegativity difference. 32. What is the correct Lewis dot diagram for a compound of calcium fluoride? I think calcium is a metal. Fluoride, that's fluorine, so a metal and a non-metal. That means I'm ionic. So if I'm ionic, before I do anything, let's crisscross. So I'll actually do it over here. I have Ca, which is plus 2, and F, which is minus 1. So if you crisscross that, you get CaF2. So when you go to draw this, I'll draw it right here. Your metal, you always just write, it loses its electron, so it's just plus 2. But then plus, you always put the second thing in brackets with 8 dots when you're ionic, because you're going to give it its charge, because it's going to be ions. But remember over here, I just said it was CaF2, so I need 2 F's. Ca plus 2 plus 2 F minus. 34. Draw a diagram that shows hydrogen bonding between ammonia molecules. Use dotted lines to show hydrogen bonds. All right, so let's think, what is ammonia? I'm actually going to go, I have room right here, so I'm going to draw this right here. So this is number, what number was that? This is 34. Right here, 34. So ammonia, what is ammonia? Well, ammonia is NH3. So if ammonia is NH3, well, it looks like this, NH3. Well, remember that this would be a polar molecule, it's asymmetrical, so it has poles, so it has partial positives and partial negatives. And it's going to be partially negative, where H's are all going to be partially positive. So if they want you to draw hydrogen bonding, what they want you to do is kind of link up these positive and negative charges. So if you drew another one, let's say I drew another one right here. Well, the N is still partially negative. Well, the H's are still partially positive. You wouldn't have to draw this, but that's still true. So that means an H right here might be attracted to that N. So you show the attractions of the dotted line. And then maybe we have another one floating over here. Anyway, this N says, well, I actually like this H. But this H says, well, I actually like that N. So, and maybe this H says, well, I like that N. So what I'm showing here in my dotted lines is my connection. So this represents hydrogen bonding. You could do it with water, which you're much more familiar with, where you take, remember, I've got my partial negative, partial positive. You're much more used to that, but this is the same thing. Okay, 35. Draw an electron dot structure of fluorine molecule F2 in iodide ion I-1. Well, F2, if I go to draw that, I'd say F. I'm going to add up my valence electrons. F has 7, so really F2 is 7 plus 7. So I'm going to get 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm done. Here's my F2. Now my iodide ion, I'm I-1, so I has 7 valence electrons, but it gained 1. So I would draw I, and now it actually has 8 valence electrons. But since that happened, I have to put it in brackets with a -1 charge. So my lighting's going away a little bit here. Can I fix that? A little better. Okay, so we are still moving. 36. Explain in terms of structure and or distribution of charge why CO2 is a nonpolar molecule. So if they were saying in terms of structure or distribution of charge, you can either say that it is symmetrical, which I'd be saying because it's nonpolar. So symmetrical, or it has an even charge distribution. If it was polar, it would be asymmetrical and have an uneven charge distribution, but since it is nonpolar, that's why you could put either one of these, that or that. So 37, explain in terms of electronegativity why the CO bond in CO2 is more polar than the F bond in F2. Well, those are going to have zero electronegativity difference. These are at least going to have something. So in terms of electronegativity, this automatically is going to have more. So just like the other question, greater electronegativity difference. Which atom, when bonded as shown, has the same electron configuration as an atom of argon? Well, I'm going to show you this actually via the answer. If I have H2, which I have right here, H now has 2 electrons. So I'm going to look if H normally had 1, and all of a sudden it had 2, it would turn into neon, which has 2. But let's see, S normally has 6, and if it gains 2 more, because look, it's got 8 around it. So if S gains 2, it turns into argon. So the answer is not H2S because the H turns into helium, but the answer is just S. Okay, end is in sight. Look at that, a half page. We can do it. Okay, use the following information to answer questions 39 to 42. Metal X is recovered from a rock sample and found to combine with iodine in a ratio of 1 to 1. 39, what is the oxidation number of element X? Well, iodine has a -1 oxidation state. If you look on the periodic table, here's the top one. So that means if it's a 1-to-1 ratio, then I need my metal to also have a +1 oxidation state. It's got to be 1. So a plus balances out a minus. So +1. 40. What is the most likely type of bond formation between element X and iodine? Well, X we said was a metal, iodine is a non-metal, so a metal plus a non-metal. So I know that that type of bond is ionic. Oh, my phone is ringing. So distracting, but we're almost done. I cannot answer it. Just like if anyone calls you, don't answer it. Study chemistry. Okay, 41. Explain in terms of electrons why element X is a good conductor of electricity. We said that element X was a metal. Ooh, metal. Focus on that. It's a metal. So in terms of electrons, electrons are mobile. So metals have mobile electrons. 42. When element X reacts and forms an ion that is smaller than the radius of the atom of element X, explain why. So basically the ion is smaller than the atom. Well, the ion is +1, so the ion loses electrons. The atom doesn't. 43. Explain in terms of electronegativity why PCl and PCl5 is more polar than PS bond and P2S5. We have seen this question now 3 times, but with different things. Well, I don't need to look anything up. I could look this up on table S, but in terms of electronegativity, if it's more polar, it's got a greater electronegativity difference. What type of bond would be formed between P and Cl and PCl5? So the type of bonds, was it ionic, covalent, metallic? Well, PCl5, that is 2 nonmetals, so nonmetal plus nonmetal. So that is covalent. If you want to get really fancy, PCl would be a polar covalent, but I would be safe and just go with covalent. And that officially wraps it up. Thanks, guys, for hanging out with me and doing the bonding Regents Prep. This is going to be a breeze on your Regents. You'll do awesome. Bye.